guys, today we are talking about the triangle sum theorem, and it's a little bit of a review of triangles. We're starting this brand new unit today. It's unit 3. Should be pretty exciting to it. Some of you, this will be a good review for you, some of the skills and everything else. Some of you, it should be okay. Can you pass this back, Tyler? Excellent. So we're going to classify triangles by their sides, talk about angles. We'll keep doing this. I'm going to try making this really quick for you guys today. You guys can have some time to work on your assignments, etc. So here we go. Really quickly, how do you classify a triangle by its angles? I know this isn't written on there, but what are 3 ways you can classify a triangle by its angles? What type of angles could you have? Yeah, you can have acute angles. If all 3 of them are acute, then you have an acute triangle. You could have a right if there's one right angle, that's right, and the last one was obtuse. Right? If you have one obtuse angle, then you're going to have an obtuse triangle. If you have one right angle, it's a right triangle. If all 3 of them are acute, then you have an acute triangle. Okay? That's by the angles. Okay? Now by the sides, these are the other 3. These 3 are by the sides. Scalene, how many sides are congruent? 0. Isosceles, yeah, at least 2. And equilateral, all 3 sides are congruent. Pretty easy. Hopefully you guys have these things written down, because we'll be classifying triangles by their sides and angles. For instance, shuffleboard. Classify the triangular shape of the shuffleboard scoring area in the diagram by using the sides and measuring the angles. Okay, by sides, how many sides are congruent? 2, so that would be isosceles. And we're just going to do this just by looking today. This angle right here looks kind of small. This one over here looks kind of small. This one over here looks kind of small. So I'm going to say those are all acute. So it's an acute isosceles triangle. That's how I would say that. Acute isosceles triangle. The third thing that we would do is we'd actually use our 3 and 1s and we'd measure all 3 of these angles here. I just don't want to waste your time doing this. But if we did, we would come up with the idea that, hey, this triangle, all 3 angles added together equals 180 degrees. Okay, and so that's what I'm going to put down here as well. We could try measuring all these different triangles and try getting all the degrees and everything. But when you add all 3 angles together, you're always going to get 180 degrees. Okay, so that concept brings us to triangles. Okay, it brings us to triangles like this. So here's the concept: if all 3 add up to 180 degrees, we just say x plus 52 plus 55 equals 180. Okay? From there, it's just an algebra problem. This is one reason, this is really what algebra geometry is about, is you're taking some geometric concept and looking at it algebraically. That's why it's called algebra geometry 2. Okay? So what we're going to do is we're going to add 52 and 55 together. We would have x plus 107 equals 180. What do we do from there? Yep, we subtract 107 from both sides. Very good. And x will then equal 73. Okay? So the idea here is it says, use a triangle sum conjecture to find the measure of the missing angle or angles in each triangle. Show all your work, circle your final answers. This says x equals 73. I'm also going to write 73 up here. Show me that's what the actual angle measurement is. You're going to see why I do this a little bit later on, because sometimes you're not just going to have x as your angle. Sometimes it'll be something like this, like 2x or x minus 6. And we'll have to go about and actually figure out what the measure of the angle is. We solve for x first, we'll actually substitute it back in. Someone want to volunteer? How do we set up the second triangle? How do we set that up? Please. X minus 6, yep. What's this angle measure? 90, so we're going to say plus 90 equals 180 degrees, right? Sounds good to me. Okay, so we just add these up. 2x plus x is 3x. 90 minus 6 is 84. Equals 180. What do I do then? Subtract 84 from both sides. I hope I'm not going too quickly for you guys. I'm just really excited about this like this. We'll divide both sides by 3. 9 divided by 3 is 3. 6 divided by 3 is 2, so x equals 32. Okay, am I done? No, I'm not. Okay. Here's the deal. This angle is 2x. So is it 32? No, it's 2 times 32. I'm going to write 64 next to it because that's 2 times 32. And this angle down here, well, it's not 32 either. It's actually 32 minus 6, or 26 degrees right there. Okay? So sometimes you have to go back through and you actually have to plug these numbers back in, so substitute. So even though you got 32 as an answer, you need to come back through and actually substitute them back into the original problem as well. Okay, just making sure. Okay, these are some special ones. These are the last two on the page, is that right? Okay. These are both very special triangles. We say 60 plus 60 plus x equals 180. If we combine like terms, we have x plus 120 equals 180. If we subtract 120 from both sides, we'd get x equals 60, and that's what this measure is. Okay? What would be another name for this triangle if it's 60, 60, and 60? Ooh, be careful. Equiangular. 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 Okay? It's also kind of a special triangle here that we'll look at. Why don't you guys try this one on your own? Try this one on your own for just a little bit. Try it on your own. Pretty simple concept that all we do is we basically add everything together. Has to equal 180. When you're done, you can look at the answers on the board. I'm not going to say them out loud. Some of you guys are still working them out. Raise your hand if you got them right. This is a special triangle. This is a special triangle here. We will look at these in particular a little bit later on. But it's actually called a 30, 60, 90 triangle. And there's special properties about the actual side lengths and everything that go on with a 30, 60, 90 triangle. And we'll look at that more either later this year or when you have Algebra Geometry 3. We'll also look at that. Yes, ma'am. See how this says 3 times x? What's 3 times 30? You got it? Good question. Other questions on this? Yes, sir. You could just make a box here, that's right. Yeah, I agree. I have never taught Algebra Geometry 3. That's one of the only classes I've not taught here, at least on the west. There are 3 teachers right now, Miss Gant, Mr. Cry, and Miss Adams. Mrs. Adams. Miss Adams is really nice. Okay, look at the very back side, the last page, last 2 problems. These are the last 2 problems in your homework. They get a little complicated. I just want to clarify a couple things here. Okay, I just want to clarify this just a little bit. These arrows point to both these 2 angles in here. Both these angles are 7x plus 1. Okay? So what you'll do is, well, you'll know this is 38. Let's pretend we solve this, and whatever, let's just say, I don't know, x equals 2. This is not correct. X does not equal 2, so don't write this down. Let's pretend it did. So we would say 2 times 7 is 14, plus 1 is 15. I'd write 15 right here. I have to write 15 like over here. 2 times 10 is 20. This would be 29 right here, so I'd write 29 here. And I guess since these 2 are vertical angles, I also have to say this is 15. Obviously, that's not right because, you know, 15 and 29 have to add up to 180, so we'd have some problems there. Okay? But the idea here is once you solve for x, then you'll go through, you'll substitute, and it'll actually be the same angle here and here and here. And this would be the separate one there. Okay? The third one here, or number 10, I guess, you kind of need a third angle. Okay, you got to do a couple different things here. First thing I would do is I would look at this triangle right here, okay, and solve for x. Okay. Once you know what x is, so what I do is, let's just say, again, I'm going to just say something weird. I'm going to say, hey, x is 10 degrees. I know it's not right. Let's just say x is 10. Then what you have here is you have a linear triple. So you set up a second equation that would say, well, whatever your x is, plus 71 plus w, that has to equal 180 because that's a linear triple. Okay? Then once you figure out what w is, then you can use the second triangle. So this is actually like a three-part problem, is what number 10 is. Okay? It's a little complicated, but the rest of them are very straightforward. The last two I thought were a little complicated for you. Yes, sir. I'm not sure. I don't even know what number 2 looks like. By angles, are there any obtuse angles or any right angles? Okay. Well, if there's one obtuse angle, you should know what it's called. All right, guys, work on your assignments. I'm going to take a look at these tests, see what's going to go on with those, and hopefully I'll be able to get some stuff back to you for sure.